Hey folks, welcome to my channel, Number Pen. So today we have another interesting problem in front of us. So let's take a few seconds to read through the problem. Find the angle between the rectangular hyperbola xy equals 2 and the parabola x squared plus 4y equals 0. So let's take a few minutes to draw this particular curve. Draw these curves. Let me use the black pen to represent the axis. And here you have the x and y axis, right? Let me use a different colored pen. Let me use red to show your xy equals 2. I'll take a minute to draw this and then I'll explain why these curves look like this, right? And then I take the blue pen to represent the parabola curve x squared plus 4y equals 0. You draw this. So this is your parabola x square plus 4y equals 0, and this is my rectangular hyperbola, which is xy equals 2, right? So we have these curves sketched out here. Let me take a minute to explain why these curves are looking like this. So you have xy equals 2, which is represented by the red line, and we know that so these lines mean that the product of any point on the curve is always 2, which means that x cannot be positive and y negative, and y cannot be positive and x negative. So this curve, you will see this curve only in the first and the third quadrant, where you have x and y both positive or x and y both negative, right? The other point is whenever x equals 0, y tends to infinity, and whenever x equals 0, y tends to infinity, and whenever y equals 0, x tends to infinity. So that is why you see these curves extending up to infinity when I. And let me come to the parabola x square plus 4y equals 0, which means that you have x square equals minus 4y. And whenever when you say x square equals minus 4y, what we actually mean is x square being a perfect square is always positive, right? So y always has to be negative in this case, right? So this curve does not exist in the quadrant 1 and 2. It exists only in quadrants 3 and 4, where y is always negative, right? And this is a parabola, so all of you know how the parabola looks like. And so this is a quick brief about why these curves look like this, because I wanted you to understand these curves before we actually go and solve the problem. Now we have a question here: find the angle between these two curves, right? So what it actually means is these two curves intersect at some point, and we've been asked to find the angle to these curves. So let me use another color. So you got, this is the point of intersection, and we'll find out what is the point of intersection in some minutes to come now, right? And so I'm gonna do something like this. Let me erase these curves. So let me erase these equations. Let me also erase this. Yeah. So now we have the tangents to the curve. Let me take a darker color. Probably I'll use black itself here. This is one, right? So let me call this theta, and this is another curve which is alpha, right? And let me call this curve out here as beta, right? So we know what alpha and theta are, right? Again, I'm drawing your attention to the slope of the respective slope of the tangents to the respective curves. So theta is the slope of the curve made by the rectangular hyperbola xy equals 2, which is this indicated by the red portion. And you have the parabola, which is x square plus 4y equals 0. And the alpha is the slope of the tangent to the curve, which is x square plus 4y equals 0. What we've been asked to find is we've been asked to find the angle between the uh, you know uh, two curves, which means that we've been asked to find the angle between the uh, parabola and the hyperbola, right? So which is this angle, and let me call it, say, alpha 1, right? Which means we can derive a relationship between alpha, beta, and alpha 1 using the properties of a triangle, right? So I'm going to write this down here. So alpha 1 plus alpha plus beta equals 180 degrees, right? And we know what is beta. Beta is again 180 minus theta, right? Equals 180. And you got alpha 1 plus alpha, right? So now I'm gonna cancel 180 and 180 on either side, and tan of alpha 1 is equals this equation, right? Now we know what is tan theta, tan alpha. Those are nothing but the slope of these two curves, right? Xy equals 2. Xy equals 2. I'm rewriting this, guys. Y equals 2 by x. Dy by dx equals minus 2 divided by x square. And then I'm going to write the six. So this is your equation 1. And I'm going to write the second equation, x square plus 4y equals 0. Let me copy this to the next page. Let me copy the question as well so that we are keeping it plus as we solve this problem across pages. And then I have y equals, rewrite this equation, minus x squared divided by 4. 4. I do dy by dx again. I get d by dx of minus x squared, which is my minus 2x by 4. You can still factor this further and you arrive at minus x by 2. So let me take a minute to explain what we did again here. So we have one equation which is xy equals 2, and we arrived at dy by dx of this equation, right? And then we have the second equation called x squared plus 4y equals 0, and we arrived at dy by dx of that equation equals minus x by 2, which is nothing but your xy by 2. I'm just drawing your attention to the previous diagram, is nothing but your alpha, tan alpha, and tan theta, right? So what is your tan theta? It is the slope of the rectangular hyperbola curve, right? So which is your tan theta. So my this is my tan of theta, and this is my tan of alpha, right? So now I'm gonna rewrite this equation. Now I know I've been asked to find alpha 1, and so we've been asked to find alpha 1 at a particular point where these two curves intersect, right? So I have, one important calculation to do here. I need to find where these two curves intersect, right? And I'm sure all of us are quite familiar with how do we do that. Square plus 4y equals 0, which means that x square plus 4 times. Now we're going to find the points of intersection. So I do, xy equals 2. So y equals 2 divided by x, right, equals 0. And then which means I have with me x to the whole power 3 plus 8, sorry, plus 8 equals 0, which means x equals minus 2, right? And whenever x equals minus 2, I have y equals minus 1, because you have xy equals 2 at the point of intersection, and at the same time it has to satisfy the equation of the parabola as well, right? X squared plus 4y equals uh, 0. So these are the 2 points, which is minus 2 comma 1, right, where we have these curves intersecting. So now it becomes very simple. We know what is our tan theta, which is minus 2 by x square. I'm just drawing your attention to this earlier working. So I'm gonna bring this down here. So I'm gonna put this, I'll probably do this working out here. Minus 2 by x square, which is minus 2 divided by minus 2 the whole square, which is minus 2 by 4, which is minus zero point 0.5, right? Which is minus 1 by 2, which is nothing but your minus zero point 0.5. And then I've got tan alpha, which is this, which is minus x by 2, which is plus 1 because x is minus 2. So we've got our tan alpha and tan theta, which is plus 1 and minus zero point 0.5. So I'm going to rework this equation to arrive at our final answer. So my tan theta So my tan theta is minus zero point 0.5 and my tan alpha is minus 1. I have divided by 1 plus tan alpha into tan theta, which is 1 into minus zero point 0.5, which is minus zero point 0.5 again. And I'm left with minus zero point 0.3, I'm sorry, minus 1.5 divided by zero point 0.5, which is equal to minus 3. And so what is alpha 1? So tan of alpha 1 equals minus 3. And let me use a calculator to write. 71.62 is your alpha. Approximately 72 degrees, right? 71.61. Thank you. So that's all we have for today. I hope you had a good understanding of the problem on angle between two curves. Keep subscribing to my channel. Happy to receive feedback from my new subscribers and viewers. And have a good day. Thank you.